Chapter 4, Section 1, Simplifying Rational Expressions. When you see the words rational expressions, what that is saying is rational means fraction, so it's going to be a fraction, and expressions is just going to be your algebraic expression. So a rational expression, again, is a fraction using polynomials. And to simplify a rational expression, basically to reduce a rational expression, what you're going to do is you're going to factor the numerator and denominator if possible, cancel any like factors, and then rewrite the simplified rational expression. So, step number 1, factor the numerator and denominator if possible. What does it mean if possible? If you see a monomial, you cannot factor a monomial. So if you have a monomial divided by a monomial, such as this one, what you're going to do is you're just going to start canceling things out. Well, we learned in the previous chapter that you can divide, and that's basically what this is. You can divide like factors with like bases. So for this one, you know that your two negatives would cancel out, and so that would go to plus. And then 28 over 63 would reduce. 28 over 63 will reduce by 7. So we know that 7 will go into 28 4 times. And 7 will go into 63 9 times. And then as far as a to the second divided by a to the second, those are going to just cancel each other out. And then b to the second over b to the third, you're going to have these two will cancel out all but one of those, so you'll have b left on bottom. So what I would like you to see is b times b on top and b times b times b on bottom. So you can see that the two cancel out. So remember, if it's a monomial, you're just going to start canceling things out. I know it's a monomial because I only see one term. I don't see any addition and subtraction signs. For these two problems, you notice that we have addition and subtraction signs, so we can possibly factor. The one on the top, we have a binomial over a binomial. Now, when you have anything aside from a monomial, such as a binomial or a trinomial or a quadrinomial even, you must factor first. In this problem, step number 1 was not applicable because we had monomials, and you can't factor monomials. But anytime you see addition and subtraction, just remember you've got to factor before you cancel. The problem with these types of problems is people want to say, oh, well, I can just cancel out the x squared with the x squared and the 4 with the 16, but you can't do that. And the reason being is because when you throw in the addition and subtraction signs, that makes these groups. And so the only way that you can cancel out a group is if the groups look exactly the same. Well, these two groups don't look exactly the same, so therefore we cannot cancel out. And you cannot cancel out parts of groups, such as the x squared and the x squared. So what you have to do is you have to factor first. So looking at the numerator, we can see that there is an x in common. Remembering our steps for factoring. If we factor out an x, we'll get x plus 4. And then on the bottom, we have x squared minus 16. That's the difference of two squares. So remember your process for the difference of two squares pattern. Put a plus in one and a minus in the other. X squared will split into x, and the square root of 16 is going to be 4. Now, this is what we have. Instead of having addition and subtraction, these groups, what we have is we have factors. And you can cancel out any factors that look exactly the same. So x plus 4 and x plus 4 will cancel out. And that's going to leave me with x on top and x minus 4 on bottom. And remember, you cannot cancel this x with this x because this x belongs to a group. This is a group. If it helps you to group them, then do so. Alright, on the bottom, there is a 6 in common, and there is an x in common, and there is a y in common. So what I want to show you here is, remember, if you have addition and subtraction, if you have anything aside from a monomial, you have got to factor first. The first thing in factoring that we always do is look for something in common. In this particular problem, we had a 6 in common, an x in common, and a y in common. Now, when I divide out a 6xy out of this first term, I'm going to have an x squared left over. The 6 cancels out, the y's cancel out, and all but 2 of the x's cancel out. But when I factor out a 6xy out of this term, remember 6xy divided by 6xy is going to go to 1. So don't forget to write that 1, because if you start with a binomial, when you factor out, you've got to end with a binomial. And remember, we said that you should be able to multiply this back out in order to get what you started with. So that 1 is needed. Alright, on the bottom I see an x in common. And when I factor an x out, I'm going to get x squared plus 5x plus 4. Now, the trick to these is you need to factor completely, because if you notice, these two groups, again, there's nothing that will cancel here because these two are groups. Now, if I wanted to go ahead and cancel out these two x's, I could, because that's straight multiplication. There's no addition and subtraction here. That is straight multiplication. But we'll wait until and reduce this when we get to that part. So now what I'm going to do is I'm going to factor this completely. X squared minus 1 is the difference of two squares that's going to factor into x plus 1 and x minus 1. And on the bottom I still have that x, but that trinomial will factor into x and x plus and 4 and 1. Now I have straight multiplication. I have these factors up top and these factors down at the bottom. So you can cancel out anything that looks alike. So I can cancel the x plus 1's. And so your answer is going to be 6y times x minus 1. That's what we have left on top. And on the bottom we have an x plus 4. And that's going to be your answer.